planetary wind and moisture belts in the troposphere. This is a diagram in the ESRT. And the main thing is, this is all about how the Earth gets heated up. So the first thing you got to remember is Rec Schweck. So with Rec Schweck, you've got to remember, you get hot air. Hot air starts to rise, and then what does the rest of Rec stand for? All right, that's rising, expanding, cooling, condensation, clouds, which is going to make rain. So right here, this is the equator, and the hottest, the most direct, the most intense sun is going to hit in this area here. So what that's going to happen is, throughout the year, this location on average is going to be the warmest air. This is the atmosphere right here, and what it's showing you is the air start to rising off of the Earth at the equator. Okay, that's because on average it's the warmest. So rising air, expanding, this is the wet belt on Earth. That's where the rainforests are. Now, that hot air starts to rise and expand and cool. Well, then it starts to sink back to the Earth. And as it sinks back to the Earth here, sinking air is the opposite of Rec. That's the Schweck. So that's where you get your dry belts, 30 degrees north and 30 degrees south. Those dry belts are where the deserts are when you look at a picture, a satellite image of the Earth. So that's why there's deserts in these two stripes on Earth. Okay, but then you have, because there's sinking air here and it starts to spread out at the surface of the Earth, it's pushing away from each other in both directions. You're going to start to naturally get some more rising air to happen here. And you get another secondary wet belt at 60 degrees north. And then the other thing that happens with these convection cells on the atmosphere of the Earth is that you get the jet stream. So there's two jet streams. There's a jet stream here and a jet stream here. And that's because of this uneven heating of the Earth. Hottest air here, because this is the most direct sun, and this starts the whole cycle, this global planetary wind cycle. So because you get the atmospheric circulation like this, on the surface of the Earth, you get some standard wind patterns. These are the northeast winds, okay? They come from the northeast. So in general, if you're between here and here, things are going to move this way. In general, on the surface of the Earth here, things are going to move this way. That's why our weather comes from the southwest, generally, okay? The third thing is, any of these arrows that you trace, this is making a right-hand turn. Or if I trace this one, this is making a right-hand turn. Okay? And in the southern hemisphere, these are making left-hand turns. So the Coriolis effect deflects all of these winds. Here's another left-hand turn. So you've got a few things happening with this diagram. You can figure out what latitudes are certain winds going at. Okay, let's do a couple practice ones here. If I have location A here, this would be a latitude of what degree, do you think? So you're looking over here. This would be between 0 and 30 degrees. This would be maybe 15 degrees south. Okay. What direction are the winds moving at 15 degrees south? They're coming from the southeast, and they're blowing that way. Average climate, okay? At 0 degrees, it's wet. At 30 degrees each way, it's dry. And then there's another wet belt. Those are the kinds of information that you'll be asked about. Let's look at a few practice questions on those. And hopefully this chart makes sense. Okay, so let's see the air over the equator. So we're going to look at the equator, and it's rising. So why does it rise? Let's look at that chart and see if we can figure out which answer we'd pick. So when you look at the chart, you just have to find different locations. The equator is going to be the easiest one to find. It's right here. And so then you can look and see what's the moisture conditions, what's the air conditions on top, and go from there. All right, so which of those, the equator, you have rising air. Okay, the air is moist and hot, low density, so it'd be choice 2. How did I know it was low density? Well, when I'm looking here, I can see that that air is rising up, so that must be less dense. That's why it rises. The other thing to remember is low versus high pressure.
This air on the chart right here is rising up off of the surface of the Earth, so it's not putting pressure on the Earth, so that's a low pressure area. And then this air right here is sinking down to the Earth. So any air that's sinking down to the Earth is high pressure. It's squeezing down on the Earth. High pressure areas, low pressure areas are where the air is rising up off the Earth. That's where lows and highs come from.
Okay, so what information are we looking for on the chart there? High air pressure, dry climate belt. What latitude?
I can work backwards or forwards on multiple choice questions. They gave me latitudes, so I can pick each of those latitudes and go to that proper section on my chart, okay? Or they told me a high pressure and a dry climate belt. So I'm gonna directly go to dry, 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 and dry, and look at those different latitudes. What's that conditions of each of those latitudes?
So from looking at the chart, it was dry climate belts at 30 degrees north. All right, which planetary wind pattern is present in areas of great rainfall? So rainfall, that's a wet thing. So let's look and see if we can find where it's wet.
Okay, so I look for those wet belts, and if I pick one of those wet belts, like say this one right here is the easiest to look at. This is the hardest thing probably as far as verbiage or terms. See the air right here? Those two arrows are coming together. This is called convergence. So the air is converging and rising at the wet. And for the dry, the air, see those arrows going apart? Kind of like when we did plate tectonics. That's diverging air because those air currents are going apart at the surface of the Earth for the dry, and they're coming together. They're converging at the surface of the Earth for the wet. They also rise here and sink there.
It looked like it was wet where the winds were converging, so they were coming together and rising up. Why do most hurricanes change direction when they pass over the 30-degree north line? Let's look at our chart for that. So you're really just writing out, describing what you see in the chart. Sometimes that can get you complete credit.